Hello, I'm going to be doing my week 5 physics. Two questions here. We're going to start off with question 9. A 36 kilogram girl is bouncing on a trampoline. During a certain interval after leaving the surface of the trampoline, her kinetic energy decreases to 160 from 430 joules. How high does she rise during this interval? Neglect air resistance. And since neglect air resistance is very important in the situation. So we have a trampoline here. We have a trampoline here. Let's just draw this. And she's jumping on this trampoline. Boosh, 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 boosh. Okay. At this low potential energy height right here, where she's jumping, she has 430 joules of kinetic energy. This would be her initial kinetic energy, and then her potential energy would be, low. And then in a certain time, right here we have h, which is what we're trying to find in this situation. We're trying to find height. She jumps up pretty high. That's actually really high. And she gets to 160 joules is going to be her kinetic energy final. And her potential energy is going to be pretty high. So in this situation, her mass is 36 with the SI units of kilograms. We have her kinetic energy initial, which is 430 SI units joules, and then her kinetic energy final, which is going to be 160 joules in this situation. Let's see here. We're going to be using the conservation of energy equation here, which is K E initial plus K E, nope, I'm sorry, P potential energy initial equals kinetic energy final plus potential energy final. And we're doing this since no mechanical energy was lost. And we're going to reshape this formula into something we're going to use for what we have, which is kinetic energy, initial kinetic energy final. So we're going to change it to kinetic energy of the initial minus the kinetic energy of the final in the situation is going to be equal to mass times gravity times height. And since we're doing this because potential energy equals the decrease in kinetic energy, and whatever kinetic energy is lost turns into gravitational potential energy. But this is the formula, and we're just gonna minus these two here. 430 joules minus 160 joules. Basic math and produces 270 joules, and we're gonna use this for this equation right here, which is H equals 270 joules divided by 36 times 9.80. There we go. And this is going to give us, let's see here. Where is it? 352.8. And we're going to have to, we're finding the denominator. This is the denominator. And then we're going to get the actual h by dividing 270 divided by the denominator we just got, which is 352.8, which is going to equal the final answer of 0.765 meters. Let's check back here. 0.65 meters, and that is correct. That's my first question. Let's give her hair here. For my second question, I'm going to be doing question 13 here. Which one of the following statements concerning the principle of conservation of energy is false? So we're looking for the false one here. And after reading through all of them, thermal energy may be converted into kinetic energy, and kinetic energy may be converted into thermal energy. Chemical energy may be converted into thermal energy and or gravitational potential energy, both true. Kinetic energy may be converted into gravitational potential energy and heat, true. The total energy in the universe has a constant value, and that is true. The only one I left out here is the right answer. The net work done on an object must be 0 joules, since energy is neither created nor destroyed in the process. And this is false, completely false. And we know it's false because the net work is equal to collection of kinetic energy here. This is the equation used for something like that. And if kinetic energy changes, then net work done is not going to be 0. It's not going to be 0, which goes against what this is saying. And only 0 if the object with the kinetic energy stays the same. Constant, that's the only way that the net work would be 0. So let's give an example here. If we have a box here, right, and it has the initial speed of, the initial the box is speeding up, so it's faster. The initial kinetic energy, let's just say it's, I think I used 20 joules here. And the kinetic energy of the final over here would be, pretty sure I used 80 joules. In this situation here, what are we going to do to find the net work? Well, we're gonna subtract. We're going to do 80 joules minus 20 joules. It's going to be equal to 60 joules, which is not 0. Not 0. And the equation we used here is kinetic energy final minus kinetic energy equals the net work done. And those are my 2 questions for week 5, explaining question 9 and question 13. I'm done.